Okay, so I'm going to do a tutorial on the Earth Viewer for Module 5, Geologic Time and Fossils. Um, so I just got done doing the Lab 2 tutorial, so this you'll see a few weeks later, but I look the same. Because we're using the same uh, program. I love this Earth Viewer. And it was so cool to use for plate tectonics, but now we're going to utilize it for geologic time. So after you've seen the lecture video, you should be familiar with some of these names, including the Phanerozoic. If we go to ancient Earth down here, we see the Proterozoic, the Archean, and the Hadean. And the reason they're in different sort of tabs here is, oh, can I make it big? We're gonna make it big, is for because well, okay, let's look. We're gonna go to view. You can keep everything that I've had for plate tectonics. I like to keep the grid. I like to keep the coastlines. But now we're going to hit biological events and mass extinctions for funsies, I think. Oh, nope, I totally lied to you. I apologize. We're going to hit fossils. Duh, because we're learning about fossils. You can hit these other ones and sort of play around and see what those are too, because they're really cool. Again, this is one of the coolest simulators that I have ever found. And so I'm so glad we get to utilize it for this class. So play around with it, but we want fossils for the fossil lab. Duh. All right, I'm going to click view so that goes away. And if you note, so each one of these little blue triangles depicts a different fossil. I'm going to drag this bad boy down to the bottom, to the Hadean. The Earth is on fire. Because it was. This is the very beginning of Earth, 4.6 billion years ago. We're going to drag it up, 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 up. Obviously, you can see not a lot's happening on Earth in this time. We get to the first fossil. This is the Strelly Pool. Oh, it's so cool. And I talk about this in the video. These are some of the first stromatolites that we have found. The first biological entities that have then sort of brought oxygen into the atmosphere. And then we're going to keep going up and up. And as you'll see, there's not a lot that's happening from the Hadean to the Proterozoic. Just not a lot. So that's why we're not really utilizing ancient Earth. We're going to utilize Paleo Earth. And you'll see there's a lot more stuff that is happening with Paleo Earth. So I'm going to go all the way down to the bottom. And I ask you for specific fossils throughout the assignment. And the first one I ask you for is the Burgess Shale, which I hopefully get to visit this summer. I'm so excited. I have been wanting to go to the Burgess Shale. I'm going to say this in my lecture video too, so you're going to have to just hear this twice. But I've been wanting to go to the Burgess Shale for years. And this summer, hopefully I get to go if it's not on fire. Fingers crossed. So we're going to go to the Burgess Shale. What's cool about this program is it shows you approximately where it formed. And the Burgess Shale is 500 million years old. So this was part of the Cambrian period. These are some of our oldest fossils that we have in the world. But I guess I shouldn't say the oldest, but they're the most diverse fossil assemblage in the world. And it shows you about where it formed geographically and environmentally. So this was part of the lecture video too. You're going to consider the environment in which these fossils formed. So look at where the Burgess Shale is. You can read a little bit about it here. And right now, let's go up. The Burgess Shale is located in Canada. It's only about an 8-hour drive from where we are, you guys. This is why it's such a big deal. If you have the chance, you should go. It's a World Heritage Site. I'm going to say all this on the lecture, so sorry you get it twice, but it's a World Heritage Site, so you actually have to book a hike through. You can't just willy-nilly go walk through it. But here's where the Burgess Shale is now. But what I want you to think about for this lab is not where it is now, because right now it's part of the Canadian Rockies. But you're going to go back to the Burgess Shale here. Where did it form environmentally? Was it part of a mountainous system back in this day? I'm not going to tell you. Hopefully you can see and read the snippet because it might actually give you a little hint in here as well. But this is where these fossils formed. And then over time, as tectonics moved all of this around, where are those fossils located now? Right? That's not necessarily where they formed or how they formed, but this is where we find them now. So I have you go through, I think, 5 or 6 different fossils, and you're going to move up. I think I have you look at the Rhynie chert as well. Here's where the Rhynie chert formed. I don't remember. I have you skip that one. Germania, I actually have you look at this one, because look at this cute little fella. The other thing that I ask, and I am going to mention it here because as I was writing this question, I was like, I want to word this well, but I think it would be worth explaining, is what I want you to look at is how have these fossils changed over time? And I know that seems really open-ended, but what I want you to think about is something like the Burgess Shale. Um, let's see if I can find the Tiktaalik. So here's the Tiktaalik um, fossil that we have found versus the Mylodon. So these are the most recent fossils that we found. The La Brea tar pits, so cool. The Olduvai Gorge and Lucy. Think about how, I'm trying to explain this without necessarily giving it away. Think about how they have changed. I guess, how have these fossils evolved over time? You're not going to necessarily be wrong in this question as I ask it. All I want you to think about is how different something like these fossils are versus something like the Tiktaalik. Okay? Think about bones, think about structure, think about how have some of these organisms advanced or not advanced over time. And I do want you to explain in detail what you think, what you see on these fossils here. So this is not an AI question that you can ask. I want you to honestly go up and look at all these fossils and take a look at what some of these look like and just be like, I think some of these fossils have changed for X, Y, and Z, like the Archaeopteryx, I picked the worst one to pronounce, has these bone structures. And I think these bone structures have changed since we've gotten to Lucy in this way. So when you see that question, and if you're really confused and you're like, oh my God, I can't get this right. I'm not looking for a right answer necessarily. I'm looking for how you are analyzing these fossils just by looking at how they have changed over time. The other thing that I'm having you look at is you're going to now understand or at least denote words like Ordovician, Devonian, Carboniferous, and you're going to look at the time period up here in the top left to utilize how many millions of years ago this was. Now, the last thing I'm going to have you look at is charts. So we haven't used charts yet. But I wanted us to look at how carbon dioxide has changed over time. Oh, this is such a cool program. I love it so much. So here's the here's the concentration of carbon dioxide throughout geologic history. To move this line here, you actually have to go over here and move this bar as we've been moving it. And I like that because you're going to move it until you get to, I think, the highest concentration of carbon dioxide. This is in parts per million. So basically, if we have a box of molecules and there's 1,000,000 molecules in this box, 6,145 of those molecules in this box is carbon dioxide. That's what parts per million means. And you're going to look at this and assess how much is in the highest, and you're going to scroll to the youngest and find, we might have to, I think it's 391. My boxes, you should be able to see it, but because I'm screen sharing and recording, it's not showing me. You're also going to look at the time periods. How long ago was this, both in millions of years and Cambrian period? And then up here in the Neogene, and this is zero, oh my God, 0 millions of years ago. So right now in the present, it's at this. And then you're going to assess how that carbon dioxide has changed. I think we're also going to look at oxygen. I don't think, I know. And we're going to look at how temperature has changed. So we're going to look at those 3 under charts. They're really, really cool. We're still going to utilize this to see how it's changed. Okay, so that is this activity for lab 5. It's so cool. Okay,